Hey everyone, I'm Dr. Pruna Gupta, and I'm so glad you're here. Today, we're going to dive into the absolutely fascinating world of medicine.
Have you ever really stopped to think about it? You take this tiny pill for, say, a headache, and somehow it just knows what to do inside our incredibly complex bodies. How does it know exactly where to go and what to fix? It almost feels like magic, doesn't it? Well, it's not magic, it's pure science. And in this explainer, we're going to pull back the curtain and unravel this very mystery together. You ready? Let's get started. Okay, so to really get how a medicine works its magic, we have to start with the absolute basics. So first things first, let's define the very foundation of this entire field, pharmacology.
So, what exactly is pharmacology?
Well, the official definition says it's the science of drugs and, crucially, how they interact with living systems, like our bodies. But let's break that down. The two words to really focus on here are drug and interaction. You can almost think of it as a conversation, a chemical conversation happening between a medicine and the cells in your body. And you know what's really cool? The word itself gives us a huge clue. Pharmacology actually comes from two old Greek words. You've got pharmakon, which means drug, and logos, which means study. So you put them together and what do you get? Literally the study of drugs. See? Super simple when you break it down. Now, pharmacology isn't just one big thing. It basically stands on two main pillars or branches. And these two branches explain the entire two-way street, that conversation between a drug and our body. Because, you see, it's not just about what the drug does to us, it's also about how our body responds and handles that drug. And here they are, our two pillars, pharmacokinetics and pharmacodynamics. I know, they sound a little intimidating, but stick with me. Let's use an analogy. Imagine you're mailing a letter. Pharmacokinetics is the entire delivery process, how the letter gets picked up, sorted, transported, and delivered to the right mailbox. It's all about what the body does to the drug. Then you have pharmacodynamics. Well, that's the message inside the letter. What does it say? What effect does it have on the person who reads it? That's what the drug does to the body. One is the journey, the other is the action. So it makes sense to start with the journey, right? Before we can even talk about the message, we have to understand how the letter gets there in the first place. So let's follow a drug from the very moment it enters our body to the moment it leaves. This whole journey is the heart of pharmacokinetics. And this journey has a very famous acronym you'll hear all the time. ADME. ADME. A is for absorption. That's how the drug gets into our blood. D is for distribution, which is how it travels through the body to reach its target. M is for metabolism. This is where the body, usually in a liver, chemically changes or breaks down the drug. And finally, E is for excretion, which is how the body gets rid of the drug, often through the kidneys. So there you have it, ADME, the complete life cycle of a drug in the body. Okay, let's switch gears. We've covered the journey, the kinetics, the drug has reached its destination. But what happens now? How does it actually do something? This is the exciting part, the action sequence. And this is the world of pharmacodynamics. This is where things get really clever. Most drugs work by interacting with very specific targets on our cells called receptors. The easiest way to think about this is a lock and key model. A receptor is like a lock on a cell. The drug acts as the key. If the key fits and opens the lock, causing a response, we call it an agonist. But what if a key fits into the lock but just jams it, preventing it from opening? We call that an antagonist. This simple lock and key model explains how different drugs can have such incredibly specific effects. All right, so we've looked at the how drugs travel and how they act. Now let's zoom out a bit and look at the why. Why is this field so important, and what's its scope in the world of health and medicine? You see, pharmacology is a massive field. It's right at the heart of discovering new medicines. But it also includes toxicology, which studies a drug's harmful effects, and clinical pharmacology, which focuses on drug use in actual patients. Then you have areas like pharmacovigilance and regulatory affairs to make sure our medicines are safe and effective. It's a science that really impacts every single one of us. So, for those of you studying B.Pharm or preparing for exams like GPAT, you might be thinking, okay, this is fascinating, but how can I become a part of this world? Let's explore some of the exciting career paths this knowledge opens up for you. Your pharmacology knowledge is like a gateway to so many opportunities. You could go into academia, teaching, and doing research. The pharmaceutical industry is always looking for experts in research, development, and even sales. You can work in hospitals as a clinical pharmacist or with the government in drug regulation. There are even careers in medical writing, communicating this vital science to others. The possibilities are truly diverse. We have covered a lot of ground today, from the definition of pharmacology all the way to career paths. To make sure all these concepts really stick, let's consolidate everything we've learned into a single, powerful visual map. This will be perfect for a quick revision session. And here it is, our mind map. It all starts with pharmacology, which branches into kinetics, what the body does to the drug, or ADME, and dynamics, what the drug does to the body, with mechanisms like agonists and antagonists. All of this falls under the broader scope of pharmacology, which in turn leads to all those diverse career paths. You see, everything is connected. So, to quickly summarize, what did we learn today? We started with the definition of pharmacology, the study of drug interactions with living systems. We then broke it down into its two pillars: pharmacokinetics, the journey, which is ADME, and pharmacodynamics, the action, which is receptor theory. And finally, we saw its huge scope and all the career potential it holds.
All right, you've listened patiently. Now it's time to check your understanding. Let's see what you remember with a few simple questions. Don't worry, you totally know this.
Here's your first question. Is the answer A, B, C, or D? Think back to that letter delivery analogy we used. Feel free to pause here and think about your answer. Question number 2. This is all about the drug's journey. What are the 2 missing steps in that ADME process? This one should be fresh in your memory. And for our final question, let's focus on pharmacodynamics. Remember our lock and key model? What do we call that key that opens the lock and produces an effect? Fantastic work! By engaging with these concepts, you have just built a really strong foundation in the fundamentals of pharmacology. This knowledge is going to be incredibly valuable for your exams, your studies, and your future career. I'll leave you with this thought from Voltaire. While pharmacology gives us these powerful tools, it's part of a larger art of healing. It's a great reminder of the delicate balance between hard science and nature itself. Thank you so much for joining me today. I really hope this explainer has clarified the basics of pharmacology for you. Keep that curiosity alive, continue studying hard, and I wish you all the very best. Dhanyavad!